accept. And now, okay, guys, do you see my my desktop? Let me. Okay, guys, if you want if you have troubles, guys, in every moment you can turn on your microphone and you can stop me. Okay. Because if you write simply on the chat, in most cases, I will not be able to see you. On the contrary, if you stop me by turning on your microphone, don't be scared, stop me whenever you want. Okay, guys. So yesterday we started by looking at function. After having provided the general definition of function, the main concept related to function, we started by looking at simple or elementary function. What's going on? Let me see. Another student wants to come, so wait a little bit. No, he will wait a little bit. Why the procedure? Okay. So yesterday we started by talking about. See? Yes.
I can only see a black screen.
You are guys. Other students have the same problem.
Me too.
Yes.
Yes.
Oh no! But why? Why? I hate team. Why? Now I try to close again. Let me wait, guys. Ma perché? Why is doing that?
And there are still some students waiting to be accepted.
Yes, I'm trying to accept them. Team is slow. Yes, thank you. I'm still trying to accept them, but guys, I try to close and to go inside again, or maybe I try to do abandon, and I will be back immediately. Okay, I try to see if it works. Let me see if it works. I still have to. Quanto è lento, team. Accept. I'm accepting, guys. Accept. Now let me share again my desktop, hoping it works now. I hope, but I do not know. Are you able, guys, to see now?
No.
No.
Nope.
Why? Team is so slow. Why? I try again. Ma miseria. I'm sorry, but I don't know why it doesn't work. I thought to share. I share it again. Let me share again. You really see nothing. Do you see my desktop at least, or?
No, it's just a black screen.
Still a back screen. But
yeah, it's black.
What is it here? So I try to get out again. We'll try again, guys. Accept.
Yes, now I can see your screen.
Oh, thank you, thank you. I hope it.
Yes, me too.
But sometimes Teams gives this problem. Yesterday I had the same problem with another class. I did it 3-4 times. I get inside and out Team 3-4 times, and at the end worked. But well, we hope. Thank you, guys. No, this is my team. Now let me see. We are crash course mathematics. So we were studying line and parabolas. So let me share. Yeah, we were studying parabolas. Okay. Yesterday we saw the general equation of the parabola, some special cases, but I told you that you don't have to remember those cases. And remember which, like for the straight line, C represents the intercept at the origin. And we saw different cases, but I told you that it's not relevant to remember all these cases. You remember the meaning of parabola, which is the general equation of a parabola, then it is easy to study. As we're going on, we will see other instruments to study the graph of a parabola, so it's not necessary to know all the special cases, even if I gave an overview. Another important thing to say for the moment is that if the coefficient A, which is the coefficient of x squared, sorry, is positive, then the parabola is convex, is a shape like this. If A, which is the coefficient of x squared, is negative, the parabola is concave. That is, its graph has a shape like this one. Okay, guys? Okay. Now, it is possible to show, even if, guys, this formula is not important. What you have to remember, guys, for the moment is that the parabola, the general equation is y equal to ax squared plus bx plus c. Then what is really important to remember, at least for the moment, is that if A is positive, the parabola is convex. If A is negative, the parabola is concave. Here I provided an information which is not really relevant for the moment, which is not really relevant for the moment. Yeah? What? Sorry? Don't you see? Another information, guys, here I provided the vertex of the parabola, the coordinate of the vertex, guys, but you don't have to remember the coordinates of the vertex, because when we will study, or we will review, if you want, differentiation and in particular optimization, we will find the vertex of a parabola without having the need to use this formula. However, only because it's an introduction, here I provided the formula. Please don't remember this formula. Only today a little bit we will use it, but in the future you will never, you will no longer have the need to remember this formula. This is the coordinate of the vertex. The axis of the vertex is minus b over 2a, while the ordinate of the vertex is minus b squared plus 4ac over 4a. But I repeat, you don't have to remember this formula. In particular, guys, the quantity b squared minus 4ac, which I wrote here, is called delta. Okay, this is the delta, called delta. So it's minus delta, if you want, over 4a. What's going on?
Sorry.
Yes?
Are you writing something? Because we are stuck on the same frame, special cases about parabola.
No, oh, like yesterday. We have problem like yesterday. So I try to thank you very much for letting me know. This team problem again. So I have to abandon it again. No, thank you. Tell me, advise me every time you have such a problem. So I need to abandon again. I am back. Let me share again. Team. Okay. Do you see now, guys, my screen?
Yes.
Yes, I am on the vertex. Do you see the vertex? V minus 2b minus b
Now,
over
yes.
2a. Okay.
Yes.
If I go down, you are able to see?
No.
You see?
Yes.
No.
Yes.
Yes.
No, now you see.
Yes.
Okay. No, so I go back. We are here. I told you that these are the coordinates of the vertex. And so this b square minus 4ac is called delta. So is minus delta over 4a. But I told you, you don't have to remember this formula. Thank you very much, guys. Every time you have a problem, let me know. And thank you. Thank you. Suppose now you want to plot a parabola of equation y equal to a x squared b x plus c. So this, as I told you, is the general equation of a parabola. Which are the steps necessary to plot the graph of a parabola? Here I reported the step. First of all, look at the sign of the coefficient a. If a is positive, then you know that y, that is the parabola, is convex. If a is negative, then you know that the parabola is concave. Okay, then you have to look at the intersection with the axis. Which are the axes, guys? You have the horizontal axis, which is, guys, and I'm sharing again, which is the equation of the horizontal axis, guys. The horizontal axis is the x-axis. All the points lying on the x-axis have a value of y equal to 0. The x-axis is an horizontal straight line. So which is the equation of the x-axis? X-axis, x equal to 0. No, it's y equal to 0. So in order to find if there exists point of intersection of the parabola with the horizontal axis, you have to make a system between the equation of the parabola and the equation of the x-axis. What does this mean? This means that you have to set the second-hand side of the first equation equal to 0. And so you have to solve this equation. What's going on, guys? Please, if you have something, you can let me know by turning on your microphone. Okay, so guys, you need to solve therefore this equation. Which kind of equation is this one? This is a second order equation, which is, well, a second order equation can be solved in several ways. However, I provide you the general formulas, the one which works always. Only to review. Remember, here is the formula. You have that x is equal to, let me show you, but okay, I know that everyone knows already this formula. So which is the solution is minus b plus minus b squared minus 4 that multiplies a and c divided by 2a. So b squared minus 4ac, as I told you before, is what is called delta. So remember, what does the solutions of this equation represent from a graphical standpoint? They represent, you don't see anymore?
Yeah, Professor.
Again?
Yes, again.
No, ma cos'è che non va, guys? I don't know why team is like shit. Oh. So let me go outside again. Fuck. Okay, I'm here again, guys. You see my desktop now?
Wait, not yet, but
Okay.
probably soon.
Probably not. No, I'm crying. Still not able, guys, to see it.
No.
No.
No, ma ma che cavolo c'è? It's too early, otherwise we could have had a break now, hoping that in 10 minutes everything improves, but we just started the lecture. Ma porca miseria. So I need to go out again. Guys, I'm sorry, do you see now?
Yes.
Yes.
It's very, I'm sorry, guys, I don't know what I can do. What can I do? So guys, stop me again. As soon as you don't see something, let me know. So this is, as I told you, we have to solve, to find the point of intersection of the parabola with the horizontal axis, we needed to solve this system. And then we get this equation of order 2. And these are the solutions. Okay, here is the solving formula. So what does the solutions represent? The solution represents the axis of the point of intersection with the parabola. In particular, you have 3 different cases. Case A, if the delta, that is b squared minus 4ac, is strictly positive, then the square root does make sense, and so you have minus b plus minus the value of the square root divided to 8. So you have 2 distinct solutions. So this means that in this case, the parabola crosses the horizontal axis in 2 points. So there are 2 points of intersection with the horizontal axis. In the case the delta, that is b squared minus 4ac, is equal to 0, then you get minus b plus minus 0, which is minus b over 2a. So in this case, in the case the delta is equal to 0, you get only one solution. That is, you have only one point of intersection of the parabola with the horizontal axis. So what does this mean? This means that the only point of intersection with the horizontal axis is the point of the corresponding to the vertex of the parabola. When you have only one point of intersection, the only point of intersection obviously is the vertex of the parabola. Then you may have a third case, the case in which the delta is negative. So delta negative means that you have the square root of a negative number, but the square root of a negative number does not make sense in the set of the real number. So in other terms, this equation does not have real solution, but only complex conjugate solution. So when an equation has no real solution, like in this case, in this case, the fact the equation has no real solution, it means that the parabola has no point of intersection with the horizontal axis. So you have three cases, either 2 points of intersection, either 1 point, or either 0. Ok? Di nuovo non si vede più. You stop it to see everything again?
Yeah,
Sì?
say we say that we see the same screen again.
If I move it, you don't see.
No.
No.
Ma perché, porca miseria? Guys, why? Why is such an awful thing?
Excuse me, sir, maybe you could send us this file and we can open it ourselves and you just tell and we scroll it down.
You don't have the, I think you have the file, guys. Yeah, because I uploaded yesterday. And you remember yesterday folder, guys?
Can you say again, please, where can I find it?
Were you present yesterday?
No, I wasn't.
Because it's important. Ah, okay, so you don't get access. I uploaded also, guys, I uploaded also inside this room. So now let me check. If you go, I'll tell you where you have to go. Wait, you have to go.
Yes, you uploaded yesterday. I see.
Yes, I uploaded it in file. If you go on file, you should be able to see material of the course. You need file, document. I read in Italian because I have in Italian. Documenti, general, material of the course, and inside material of the course, you can find the folder CR Mathematics. Okay, RES 2020-21, but it is the same for this year. So you should go. I uploaded it. Okay.
Okay.
While
yes,
you're trying, I go still outside. While you are opening the file, all open the files. That maybe we can try to proceed in this way. I go slowly. Stop me. I try to go outside again to try to do a last trial. I tried the last time, but okay. And then I share again, but if it doesn't work, then I think it's better if we continue. I try to go even slower, but
Guys, hi. If you haven't seen the file, I can send via a WhatsApp group that you created.
okay, guys, I try again for the last time to share it. Then otherwise, I'll talk slowly. We read it together, really. So again, open again this file. Okay. Now, I don't know. Do you see now, for the moment at least?
Yes.
Yes.
Okay,
Yes.
thank you. We are at page 11. Okay, and if you go a little bit below, I plotted three graphs. So the first graph A corresponds to the first case, the case in which you have 2 points of intersection with the horizontal axis. Case B, the case, for example, in which you have 1 point of intersection with the horizontal axis. And as I told you, in this case, the point of intersection is also the vertex of the parabola, and the case in which you have no point of intersection at all. Okay, if you don't stop to see, let me know, because I start to talk slower. Okay, if you don't see anymore, so I talk slower, so I try to read with you very slowly. Then, third point, find the intersection with the vertical axis. Well, the point of intersection, which is the equation, guys, of the vertical axis? The vertical axis is the y-axis. Okay, the point and the equation of the y-axis is x equal to 0 because all the points lying on the vertical axis have axis equal to 0. So do a system between the equation of the vertical axis x equal to 0 and the equation of the parabola. Essentially, you have to put 0 inside x in the equation of the parabola. If you do it, what you get? 0 plus c, y equal to c. And this is, and as I told you already yesterday and even at the beginning of this lecture, c is the ordinate of the intercept at the origin. That is the value of y when x is equal to 0. So in reality, you knew already this from the beginning, so it was not really strictly necessary to perform the system, because you know that when x is equal to 0, y is always equal to the constant c. Okay, so the point of intersection is this one. Then the last step, find the vertex of the parabola, and only for this lecture we use the coordinate of the vertex. In particular, guys, among these two coordinates, it's really important, only for today's lecture, to remember the axis of the vertex. And then I will show why. And it's not really important at all, even now, to remember the ordinate of the vertex, which is minus delta over 4a. Now, we try to see how to plot the parabolas. Some examples. Okay, plot the following parabolas. Suppose you have y equal to x squared minus 9, yes? If you stop to see, let me know that I go even slower, okay? So if as I told you, first step, look at the coefficient of x squared, because remember, the coefficient of x squared is a. Which is the coefficient of x squared, guys? It's like having 1 times x squared. So a is equal to 1. 1 is positive or negative? It's positive. So we find out that a is greater than equal to 1 is positive. So we know already that our parabola is convex. Our parabola is y, okay, because y is equal to this one. So y is like our f of x is a parabola which is convex y because a is positive. Then I suggested as a second step to look for the point of intersection of the parabola with the horizontal axis. So what you have to do? Again, the system between the equation of the horizontal axis, which is y equal to 0, and the equation of the parabola. Set this equal to 0, okay? You have then this equation, guys, can be solved easily without having to apply the general formula we discussed before, because you can put the minus 9 in the second hand side. So what you get? Since you have a square, you have x equal to plus minus square root of 9. So x equal to plus and minus 3. So we find out 2 points of intersections with the horizontal axis. Which are the coordinates of the point of intersection? Are plus 3 and 0, and the other minus 3 and 0. So, which is the other information we need to plot the parabola? We need to find out the point of intersection with the vertical axis. Guys, but we know already the point of intersection because which is the c of this parabola? C is minus 9. So another point of intersection for sure is, the point of intersection with the vertical axis for sure is the point 0 minus 9. However, if you don't remember, how can you find the point, if you don't remember this, how can you find the point of intersection with the vertical axis? Which is the equation of the vertical axis? Is x equal to 0. Okay, so to get the corresponding value of y, you can do either the system or simply doing this operation. Evaluate y when x is equal to 0, because remember, x equal to 0 is the equation of the vertical axis. Y equal to y of 0 means put inside x 0, so you get y equal to 0 minus 9, which is minus 9. So we find out 3 points belonging to our parabola. We find out that our parabola is convex. Now, there are several ways, guys, to find the vertex, but okay, we will not discuss to everything, all the details about the parabola, only the main concept. So I want to avoid it. how can we find the vertex, for example, guys? The axis of the vertex applies the formula. Minus b over 2a. In general, you don't have to remember it, okay? But which is, okay, minus, which is b, guys? You see, we do not have the term that multiplies x. I mean, we do not have x. B is the coefficient of x. We don't have x, so it's 0. So it's minus 0 over 2 times the coefficient of x squared, which is 1. Minus 0 over 2 is 0. So the axis of the vertex is the 0. The axis of the vertex is 0. Do we need this formula? No, at all. We don't need at all this part. Why? Because it is enough to establish the value of our of y when x is equal to 0. But guys, y of 0, which is y of 0? You have to take 0, put it inside your parabola, but we did already it before. It's minus 9. So the intercept with the vertical axis is also the vertex of the parabola. Since we find out that we already find out that our parabola was convex, that is like this. We have 2 points of intersection with the horizontal axis. Report this point. This point. We find out that this is also the vertex. Obviously, this is our parabola. Okay. We'll see other couple of examples. Do you still see the slides? The presentation?
Yes.
Yes,
Oh.
yes.
Well, I hope, we pray. Thank you, guys. I'm sorry you are so patient. I'm happy you are. No, sorry. I'm sorry, but you are so patient. Thank you. I don't know what can I do with this team. Y is equal to x squared minus 2x plus 1. Plot this parabola. Again, reason as we did previously, which is the coefficient of x squared? A, remember, because the coefficient of x squared is a. The coefficient of x, b, is minus 2, and c is plus 1. So the coefficient of a is 1. 1 is positive. So since 1 is positive, remember, the parabola is convex. That is something like this. Now find the point of intersection of this parabola with the horizontal axis. You have simply to put down a system between the equation of the horizontal axis, which is y equal to 0, and the equation of the parabola. So this means that you have to equate this to 0. This is a second. Oh, guys. Okay, there was a typo here last here. Let me see. Yeah. Probably I needed to put plus here, but let me solve it with you, because since I solved this one, I want we modify here, because I modified last year, but I forgot to say the changes. So for the moment, before checking, suppose that is plus 2x plus 1. Okay, so let me put here, then I will check, but it should plus. Okay, guys, let me see if I really solve with the plus. Yes, is x plus 1. Yes, guys, please put the plus here in the text. There was a typo here. You see b, put x squared plus 2. So b is plus 2. Okay, guys, put a type. There was a typo here. Put a plus. Okay, so in fact, you see below I wrote this one. So x squared plus 2x plus 1 equal to 0. Obviously, you can solve it in 2 ways, but first I use the general way, which is the solution is minus b, so minus 2 plus minus square root of 4. So I repeat, is minus b plus minus b squared minus 4ac. So it's minus b, so minus 2 plus minus square root of b squared, which is 4, minus 4ac. 4 times 1 times 1, so minus 4, divided 2 times a, so 2 times 1, which is 2. 4 of minus 4 is 0, so you have you are in the case in which delta is 0. So you get minus 2 over 2, which is minus 1. So we have only one point of intersection with the horizontal axis. So for sure, we are in the case in which the only point of intersection with the horizontal axis is also the vertex of the parabola. Guys, this is a way to solve it, which is the general, which works always. However, only to review, one can also make alternatively, can make an observation. Do you remember? Non mi ricordo, fate vedere. A plus b to the power 2 is the square of a binomial, and this is given by a square plus b square plus 2ab. So look at this one. X square can be seen as the square of x. 1 can be seen as the square of 1. 2x is exactly the product between 2x and 1. So what I'm saying is that x plays the rule of A, 1 plays the rule of B, and so 2 times AB is 2 times x1, which is 2x. So I'm saying that this is exactly a square of a binomial, and the binomial is x plus 1. In fact, I wrote x plus 1 square, okay? Then you want to find the value of x that makes this square equal to 0, because you want to solve this equation in another way. I'm solving the same equation, guys. So set it equal to 0. But guys, when a square is null, a square is always greater or equal to 0. So a square in particular is equal to 0 if and only if the basis is 0. So which is the basis? X plus 1, because 0 to the power 2 is 0. So the basis is x plus 1. So this equation is equivalent to x plus 1 equal to 0, from which you get x equal to minus 1. No, I did it only to review the square of a binomial. Okay, but you can solve as you like more. Okay, you can use the first formula, which works always. Instead, to solve by using this approach, you have to notice it. Okay, not only to review, guys, only to talk. So now this is the point here. This means point of intersection with the x-axis. I use this notation, intersection. Remember, this means in mathematics intersection, and this instead means union. I did this sign to simplify the notation. Really, it's not really formal mathematics. This one is only a trick I use to simplify, to write less word. Point of intersection with the x-axis is the point -1 and 0. Which is the point of intersection with the y-axis? Do we need to put to do a system? Well, if you want, you can do a system between this equation and the equation of the vertical axis, which is x equal to 0. But we know already that you can get it immediately, because, guys, which is the intercept? 1, and you know that the intercept is always the constant c. The constant c, you know, it's always the intercept at the origin. So this means that when x is equal to 0, y is equal to 1. Don't believe me? You don't believe me? Put x equal to 0 here. You get y equal to 1. So the point of intersection with the y-axis is always the point 0c, and c is +1. So we find out this point of intersection. We have the coordinates of the vertex. We have one point of intersection. Okay, I told you, yes? I told you that this is also the vertex, because we have only one point of intersection. Again, if you don't believe me, you can apply again the formula of the vertex, which is the abscissa of the vertex. I tell you guys, we wrote it before, is -b over 2a. So minus b is -2 over 2a is -2 over 2, which is -1. But as I told you, it was obvious that the vertex was -1, the abscissa. Why? Because we find out already that our parabola had only one point of intersection with the horizontal axis. So obviously the only possible case is when the point of intersection is the vertex. If you want to get the y of the vertex, as always, you don't need to apply the formula. It's simply, you have simply to evaluate y when x is equal to -1. That is, if you don't believe me, take -1, which is the abscissa of the vertex, put it here into x, -1 to the power 2 is one, plus 2 times minus 1 is minus 2. 1 minus 2 is minus 1. Plus 1 is 0. If you don't believe me, I mean, there are several ways, guys, with the parabola, I mean, to get information. But in general, here I provided a schema that can be useful, but one can follow other ways, okay? So here I plotted the graph, because here we had the vertex, minus 1, 0. Then the point of intersection with the vertical axis was the point 0, 1. Our parabola was convex, so it's very easy to plot it. Obviously, guys, even the graph is not perfect at all, but the parabola is always symmetric with respect to this straight line, which is the axis of the parabola. So this branch is always the symmetric with respect to this axis, to this vertical axis, which is the axis of the parabola, is asymmetric with respect to this branch. To continue again, guys, plot this other parabola, y equal to minus 2 x squared minus 4. So which is the coefficient, which is the first step? Look at the coefficient of a. The coefficient of a, the coefficient of x squared, sorry, is a, which is minus 2. So minus 2 is negative. So negative a means that the parabola is concave, like this. Find now the point of intersection of this parabola with the horizontal axis, that is the system, with y equal to 0. This means that you have to equate the second-hand side of the parabola to 0. Okay, now you have to solve this equation. If you don't believe me, you can, guys, well, you can, how can you solve it? Well, guys, suppose we don't see nothing. Solve it. I tell you what you have to do. Oh, maybe I did it below. Okay, oh guys, I wasn't reading here. I wrote the same thing I was saying. If you don't believe me, because here I told you that there are no real solution. Impossible means for me there are no real solution, and I explain why, intuitively why. Why, guys, didn't I try to solve this equation? I didn't try to solve this equation for a reason, because I noticed that minus 2 is negative, okay? X squared is always greater or equal than 0. So a quantity always positive or equal to 0 times a negative quantity makes a quantity which is always smaller or equal to 0. If you then subtract 4 to a quantity which is, in the best cases, equal to 0, so 0 minus 4 is negative. In other cases, this quantity is always negative. A negative number minus a negative number is negative. So there is no way to get, there is no value, no real value that you can give to x to make this quantity to be equal to 0. So for sure, there are no real solution. What does this mean? Since this solution represents the axis of the point of intersection of the parabola with the horizontal axis, this means that there are no point of intersection with the horizontal axis. However, suppose that you didn't notice that this quantity is strictly smaller than 0. Try to solve it. So you can either apply the solving formula minus b plus minus square root of b squared minus 4ac divided 2a, or simply, this is easier to solve, you can put the minus 4 on the second-hand side, and then you get 4. Now you should realize something, but suppose because the first-hand side is always smaller or equal to 0. The second-hand side is strictly positive, so for sure there are no solution. However, suppose you are still not noticing it. Go on, change the sign. Again, the first-hand side is greater or equal than 0, always. The second-hand side is negative, so you should conclude that there are no solution. However, suppose you are still sleeping and try to solve it. Divide by 2, then you get x squared equal to minus 4 over 2. Simplify, you get x squared minus 2. Now everyone should be really able to see that x squared is always greater or equal than 0 because it is a square and the square cannot be negative. So there is no solution. You can observe it immediately, otherwise do the steps until you do not observe it, okay? But never write x squared equal to -2, so x equal to plus minus square root of 2. This is stupid, okay? Does not make any sense, okay? If you got a square equal to a negative number, you say there are no real solution. I wrote impossible. Well, it should be better to write there are no real solution, to be precise, because there are solutions, but not real. And when there are no real solution, there are no point of intersection. So guys, our parabola has this shape, is concave and has never the solution. So guys, don't copy. Can be this one our parabola? No. Can be this one? No. For sure will be something like this, for example, here, something like this. But the graph of our parabola is strictly negative. So this means, since it's strictly negative, what does mean negative? The y is negative. So this means that the graph of our parabola for sure will lies completely in the third and fourth quadrant. Okay. Now we go on. Can we find the point of intersection with the vertical axis, guys? Without doing computation, we know that the point of intersection with the vertical axis has coordinate 0, c. So 0 minus 4. So 0 minus 4. And which is the vertex of the parabola? Again, we can try. Which is the axis of the vertex? Minus b over 2a. So look at your parabola. Do you have b? No. So here you have 0. 0 over 2 times minus 2. So 0 over minus 4. Okay, which is obviously equal to 0. So the axis of the vertex, why I wrote 16? Minus 2 is 4. Isn't it 4, guys? Okay, at the end is 0, but I wrote 16. Why? Is minus b over 2a, so is minus 4. Hi, guys, please put minus 4, okay, as I was saying to you. And then it's 0. Okay. Now, how can you evaluate the ordinate of the vertex? You have to, since the axis of the vertex, which has been obtained by applying this formula, you have to substitute into your function, into x, the axis of the vertex. So I wrote in this way, guys, yv, to say the ordinate of the vertex is given by y evaluated at the axis of the vertex. So this means y of 0. Put 0 here and you get minus 4. So again, the vertex coincides with the point of intersection of the parabola with the vertical axis. So this is the point of intersection, 0, minus 4. The parabola is convex. And this is also the vertex. So the parabola is symmetric with respect to this, to the horizontal vertical axis. So this is the graph of the parabola. Okay. Now for home, guys, for home, do by yourself. I mean, there are all the explanation. Do by yourself exercise D. Okay, do by yourself exercise D and exercise E. I mean, when you study, try to think about it without looking at the solution. Then look at the solution later. Okay, try if you want. If you're already able to do these things, obviously you don't need to do it. But if you have trouble, guys, do them. And guys, I reported all this. There are all the steps here. Okay, So I don't think you will have any kind of trouble. Now, before going on, guys, before going on, I want to review something very quickly about inequality, because our goal is the study of the graph, the presentation of elementary function. However, before going on with other functions, which are in particular the polynomial function, I want to solve with you, only to do a quick review, some inequalities. So only to make a review, guys. I know, but sometimes you need in mathematics to solve an inequality. Maybe if you don't remember how to solve inequality, that is the problem. So for this reason, we try to solve these inequalities. So, but they are very simple, but only to review. Guys, suppose you need to solve the following inequalities. X squared minus 4x greater or equal than 0. Okay, what does mean that we want to solve this inequality? We need to find the set of the values of x such that the first hand side is greater or equal than 0. And the procedure I suggest is by making use of the parabola. Because, guys, this is an inequality of second order. Question: what does the equation, let me see if I wrote it below so I can show you. What does the equation, guys, look at the equation first, which is the associated, not equation, sorry, consider y equal to x squared minus 4x. What does y equal to x squared minus 4x represent graphically? Well, it's the equation of the parabola. Y equal to x squared minus 4x is a parabola graphically. And we don't need really to plot this parabola carefully, but I'm asking you, does this parabola have point of intersection with the horizontal axis? How can you know? Well, you have to set, to get the point of intersection with the horizontal axis, remember, which is the equation of the horizontal axis, y equal to 0. So you have to set x squared minus 4x equal to 0, as I have done, as I did here. How can you solve this equation? Well, you can either apply the general formula. However, here you can use a faster way, because what do these two terms share in common? What do they share in common? They have in common the x, so you can collect x between these two terms. If you collect x, you have x that multiplies parentheses x minus 4. What is it? So you can rewrite this equation in this way. Now, apply a very important rule of mathematics. When, guys, a product is null? A product is null if either the first factor is null or the second is null. So this product is null if either x equal to 0 or x minus 4, the second factor, equal to 0. So x equal to 0 is already solved. X minus 4 equal to 0 implies x equal to 4. So we find out two points of intersection of the parabola with the horizontal axis. The point 0, 0 and the point 0, 4. You don't need, guys, to solve inequality. I'm showing you how to solve inequality unless you know already this. Okay, probably you know already this way of solving an inequality of second order. So we find out these are the 2 points of intersection. This one information very important. Which is another information very important is the following, which is the coefficient associated to x squared, guys. I wrote it here. The coefficient associated to x squared, that is a, is equal to 1, which is positive. So you don't have to plot the parabola. You don't have to find the vertex. You have only to find out, guys, by using this approach, two things: the point of intersection of this parabola with the horizontal axis and the sign of a. Since a is positive, guys, I'm asking you, can you have a parabola like this one? like the one, okay, I did it very poorly. Now, like the blue. No, it cannot be. Why it cannot be? Because the parabola must be convex. So what I did now, let me, come faccio? Tornare indietro? No? Questo? No. Oi, cosa è successo? Ha girato troppo? Aspettate, che adesso non come funziona questo. I go back, page 15. Page 15. Okay, so the parabola is convex and passes through these 2 points. Now, pay really attention. We now and only now we are going to look to what was required. We wanted to find the values of x such that the first hand side, but the first hand side, yes, the first hand side is our parabola, is the y, okay? The first hand side is our parabola, is y. The value of x such that our parabola is greater or equal than 0. But remember, our parabola is y. Look at the graph. For which values of x the y is positive? You see, for x greater than 4, that is here, you see that this parabola lies above the horizontal axis. So all the vertical distances are positive. Okay, all these vertical distances are positive. For x smaller than 0, all the vertical distances again are positive. So, in particular, we were asked to find out the values of x for the values of x such that x squared minus 4x is greater or equal than 0. Okay, so you have also to consider the value x equal to 4 and x equal to 0. On the contrary, for values between 0 and 4, you see that the graph of the parabola lies below the horizontal axis. So these distances are negative, but these distances, guys, are the values of x squared minus 4x computed for each of the x inside this interval. So the parabola is positive when it lies above the horizontal axis, that is for values bigger than 4 and smaller than 0. Furthermore, since here in our problem we have also the equality, we have also to consider the values such that the parabola is 0, the values such that the parabola touches the horizontal axis. So here I wrote the graph of y is above the horizontal axis for values strictly smaller than 0 and strictly smaller or strictly, sorry, or I need to use or. Why did I do? Oh, guys, probably. Please put union, guys. Guys, please. I told you that there are some typo, but I'll check with you. Typo, union. Oh, guys, in mathematics, union can be written either like a V like this or like a U. The intersection can be written either like in this way, which means and, or like a V reversed like this. However, here is union, please, guys, put a union. Now, since we need to solve this inequality with also this sign, in particular, the solution will be now I modify with you. I hope I did only here this mistake. Probably I noticed it from guys. So the our inequality is verified for minus infinity to 0, 0 included. So you see that I wrote x belongs to this parenthesis. Well, you can use it or not, but parenthesis, this one is very fundamental. Minus infinite, because minus infinite, it's an open interval here. So minus infinity until 0. 0 is included, yes. So you have to use a regular square bracket. Then here again, union, please check, modify it this means union, please, union, or a V like this. 4 included, so you have a regular square bracket because 4 is included. 2 plus infinite, remember here the interval is open. So if you want, you can put everything inside these huge parentheses. Otherwise, if you don't want, you can even avoid to report these parentheses and this one. That is x smaller or equal than 0, union. Oh, why did I do that? No, probably me ne ero già accorto. Probably I did understood. I modified it also last year, but I forgot to save the changes because I do a lot of things, and so I do not save at the end typically. Okay, now we look at another inequality. We finish this inequality, then we do a break, guys. Okay, don't be scared. So we continue until 10:30, and then we do the break. Minus x squared minus 5 smaller or equal than 0. Well, first of all, guys, what do you think about this parabola? Does this parabola, which is the associated parabola, guys? The associated parabola is y equal to minus x squared minus 5. Intuition, guys. We are interested only in two things: the point of intersection of this parabola with the horizontal axis, and we want in the sign of this coefficient, the coefficient of x squared, which is minus 1. So, how can you find the point of intersection of this parabola with the horizontal axis? You have always to set y equal to 0, because this is the equation of the horizontal axis. And you get, guys, minus x squared minus 5 equal to 0. Do you think that this is possible? Guys, do you think that it is possible? Minus x squared, guys, is a quantity greater or equal than 0, always. Minus x squared is smaller or equal than 0. Suppose it is equal to 0, guys. Minus 5, 0 minus 5 is minus 5. So this quantity is either negative or equal to 0. But since to a quantity which is always smaller or equal than 0, you subtract 5, for sure this quantity is strictly negative. So we do not have intersection with the horizontal axis. But again, if you don't believe me, do the step. You get minus x squared equal to 5. And from this you get x squared equal to minus 5. Is it possible? No, it's not possible. So we do not have intersection with the horizontal axis. Guys, which is the concavity or convexity of the parabola? The parabola is concave. Why? Because a is minus 1 is negative. So it's something like this. So guys, you have a parabola which is always, guys, who have a parabola that never touches the horizontal axis, which is concave. Can be something like this. I do it poorly. Suppose it touches here. No, otherwise we would have found a point of intersection. So it cannot be this one. Can be something like this. No, otherwise we would have found 2 points of intersection. So the parabola is something that lies always below the horizontal axis. Yes, here I did it a little bit better, but who cares? When we want to solve an inequality, you are interested only in two information: the number of intersections and if the parabola is convex or concave. Since it is concave, for sure, and since we do not have point of intersection, for sure it could be like something like this, something like what I just plotted here, something like this. But who cares? What is important to know is that our parabola will for sure always lie below the horizontal axis. So our parabola, which are the axes of all these parabolas below, are all the ordinates, sorry, are all negative. So for all the values of x belonging to the horizontal axis, that is for all the real values of x, the corresponding value of y is negative. Our parabola is negative. So the solution in this case is every x belonging to R. So in particular, guys, I make also a comment. The solution is x belonging to R. In particular, guys, this inequality is always satisfied as a strict inequality in particular. Why? Because the quantity, intuitively, guys, even without making the study of the parabola I just did with you, one can solve this inequality immediately, simply observing that the first-hand side, for sure, is always strictly negative. You see, strictly negative, minus x squared minus 5 is a strictly negative quantity. So for sure, this inequality is verified for all x belonging to R, and in particular is never equal to 0. So it's verified as a strict inequality. However, to simplify, however, the solution are simply x belonging to R. Question, guys, problems? Turn on your microphone when you have problem. So I go, oh, here I use the right sign. So maybe I was on drug. No, I'm kidding. No, when I did the first exercise. No, I'm not drug. I'm stupid without, I'm stupid enough without taking drugs. So I cannot really take drug otherwise. I'm already so stupid. So sorry. Probably I don't know what I was thinking in that moment. But when I put these signs, because I see that below I put the right sign, at least here, we'll see. 4x squared plus 6x greater than 0. We want to find the values of x that makes the first-hand side strictly greater than 0. Again, guys, you can use the trick of the parabola. What does y equal to 4x squared plus 6x represent graphically? A parabola. You are interested simply in finding the point of intersection of the parabola with the horizontal axis. How can you do that? Simply set this equal to 0. To solve this equation, okay, you can either use the general formula, or more simply, you can collect the terms in common. And here in particular, I follow this way, guys. First, I divided by 2, because you see, 4 is can be divided by 2 and also 6. And I got 2x squared plus 3x equal to 0. Then I collected x between these two terms. So I add x times, parentheses, 2x plus 3. This is equal to 0. And again, this is a product. A product is always null if and only if either the first factor is null or the second one is null. So this equation can be split into 2. First factor null implies x equal to 0. Second factor null implies 2x plus 3 equal to 0. And the solution is x equal to minus 3 over 2. So we find out 2 points of intersection of the associated parabola to the horizontal with the horizontal axis. Now, second information you need, simply the concavity or convexity of the parabola. Which is the coefficient of x squared? Is 4. So A is 4, but 4 is positive. So this means that our parabola is convex. So like this. So we know that the parabola passes through these 2 points. Is convex, is something like this. I repeat, you don't need to plot it carefully now to get the vertex, only to get the intuition. Plot it. If you plot it, when do you think the parabola is positive? The parabola is positive when its graph lies above the x-axis. So here is positive. So for which values of x? For values of x greater than 0, you see, for values of x greater than 0, the graph of the parabola lies above the horizontal axis. And for values of x smaller than minus 3 over 2, because you see the parabola still lies above the horizontal axis. On the contrary, for value of x in the interval minus 3 over 2 and 0, you see, for values of x here, which are the associated value of the parabolas, Well, these vertical distances, which are all negative. Okay, you see that these distances are negative. So, which are the solution? Now look, we are interested in a strict inequality. Strict inequality means that we do not want to consider the values of x that makes the first-hand side to be equal to 0. So the first-hand side is equal to 0 at the point minus 3 over 2 and at the point 0. So our parabola is strictly positive for values of x strictly smaller than minus 3 over 2, union x strictly greater than 0. By using the notation of the sets, I wrote x belonging to, you see, minus infinite, always never included, okay, because it's an open interval, it's not closed. Minus 3 over 2 is included. As I told you, no, because here we have a strict inequality and not greater or equal. So use a parenthesis like this or a reversed square bracket. Union, again, this interval, which is open here, so 0 does not belong to the interval because you have strict inequality and not greater or equal. So union, 0 not included, use this parenthesis or the reverse bracket. 2 plus infinite, again, use this parenthesis or the reversed square bracket. We do the last two example and then we do the break, okay, guys? Suppose, guys, you want to solve this inequality. You have x plus 2, 1 minus x times x squared plus 1 smaller than 0. Again, to solve this is a little bit different compared to the previous one, but at the end of the story is easy. So we want to find the values of x that makes the product in the first hand side to be strictly negative. So how can we do that? As we did previously we had only one factor, which was our parabola. Remember, we studied first the sign of the parabola and then we looked at this sign. So now we need to do the same thing. We need to study the sign first of all the three factors. Then we study the sign of the product. And then after having studied the sign of the product, we will select the set of value of x, making this product strictly negative. So first of all, we ignore completely this sign as we did previously. We look at this sign of inequality only at the end. So first of all, look at this one, which is the sign of the first factor. The first factor is x plus 2. So for example, you can write x plus 2 greater than 0. Guys, suppose you write x plus 2 greater than 0 and solve it. X plus 2 greater than 0 implies x greater than minus 2. But what does this mean? This means that for x greater than minus 2, so I report it here, the quantity x plus 2 is written here, is positive. So this means that if you report do a system like this one, a graph like this one, report here minus 2, here report the factor x plus 2. We want to study the sign of x plus 2. We set x plus 2 greater than 0, and we find out that x plus 2 is greater than 0 when x is greater than minus 2. So this means that for x greater than minus 2, that is on the right of minus 2, the quantity x plus 2 is positive. So report plus the sign plus. So if for x greater than minus 2, x plus 2 is positive, then for x smaller than minus 2, x plus 2 is negative. So report m minus here. Here at minus 2, what does happen? I reported a full circle, which means that x plus 2, when x is equal to minus 2, is equal to 0. So this is simply the sign of the factor x plus 2. Now, study the sign of the second factor, which is 1 minus x. Set it, for example, greater than 0. If you set it greater than 0, solve it. So you get minus x greater than minus 1. Now you want to find x. So change the sign. Remember that when you change the sign, you have also to change the verse of the inequality. So you get x smaller than 1. But what does this mean? This means that here you have to report 1. Okay, 1. Then here report 1 minus x. So read it. For x smaller than 1, go back, go here. The quantity 1 minus x is greater than 0. So for x smaller than 1, so on the left of 1, you need to report the sign is written here. The sign plus. So plus. After the 1 minus. Here a full circle because the point 1 is a point that makes the first hand side to be equal to 0. This is simply the study, we say, of the sign. Now study the sign of the second factor. Well, the second factor is a parabola because the third factor, sorry, x squared plus 1. But even without thinking too much of the parabola, guys, I'm asking you, x squared is always greater or equal than 0. If to a quantity which is always greater or equal than 0, you add a positive number, you get a quantity which is strictly positive. So plus, plus, plus everywhere. If you want to think to the parabola, we think for a moment to the parabola. If you want also to think to the parabola, guys, you have to remember that you have to look at two things. You have to look at the point of intersection, x squared plus 1 equal to 0. What do you think? Implies x squared equal to minus 1. So, which is clearly different from minus 1. So there are no point of intersection. Which is the coefficient A of this parabola? A is equal to 1, which is positive. So the parabola is convex. So we will have a parabola like this, for example. Okay, I don't want to plot it carefully because we can plot it carefully, but I don't want. Or something like this. So what I'm saying is that our parabola for sure lies always above the horizontal axis and for sure is strictly positive everywhere. So for this reason you see plus, 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 plus. Now, this is not the inequality, guys. This is the sign of the three factors. Put now them together. Minus times plus gives minus. Here you have a full circle, report the full circle here. Plus times plus times plus give plus. Here you have a full circle, report the full circle. Plus times minus is minus, times plus is minus. So in this line, guys, I studied simply the sign of the first hand side of the product. This is equivalent to study the sign of the parabola when we did the graph, because now we studied simply the sign. And now, and only now, as we did for the parabola, we look at which values of x we are interested. We are interested to the value of x, look, that makes our product strictly negative. Where? Look here at the sign. Where the product is strictly negative? For sure for x smaller than minus 2, because you have minus, and for x greater than 1. Here you see, I reported, therefore, a continuous line and continuous line here to denote that these are the intervals of x for which our inequality is satisfied. Observation. Do I need to take x equal to minus 2 and x equal to 1? No. Why? Because here I have a strict inequality and not smaller or equal and equal. So for this reason here I reported an empty circle, or if you don't like an empty circle, you can even report a cross if you don't like it. Otherwise, an empty circle is good, an empty circle. So put together, so which are the solution? The solution are given by the union of this interval and this interval. Write it formally. X belongs to the union of two intervals from minus infinite until minus 2, but minus 2 must not be included. So you can use a parenthesis like this or a reversed square bracket. Union 1, which is not included, so use this parenthesis or a reverse square bracket, plus infinite, and this something has been cut during the scanning procedure. Okay, a parenthesis like this. Guys, really last exercise and we do 15 minutes of break. Okay, only the last to conclude this type of exercises. X squared minus 9 over 1 minus x squared greater than 0. We want to solve this inequality. Again, don't look for the moment to this inequality. We need to find the values of x such that this ratio is positive, but we will look at the fact that it's positive only at the end. So to answer to this question, first we need to study the sign of the ratio. To study the sign of the ratio, we have to study separately the sign of the numerator and the sign of the denominator. Here I reported the numerator. Guys, which is the numerator? The numerator essentially, graphically, is a parabola, because the parabola of equation y equal to x squared minus 9. Remember, you have to look only at two things. The point of intersection of the parabola with the horizontal axis. That is, you have to set this equal to 0. X squared minus 9 equal to 0 implies x squared equal to 9, so x equal to plus and minus 3. So we find out that there are 2 points of intersection with the horizontal axis. Then you have to look at the coefficient of x squared, which is a. Which is the coefficient of x squared? Look, it's 1. 1 is positive, so our parabola is convex. So intuitively, which is the sign of the first factor, of the numerator, sorry. Report here minus 3, report here approximately 3. Our parabola is convex, so I'm not able to get it perfectly, but it's something like this. So for which values of x the parabola lies above the horizontal axis? Here and here, you see. So for values of x greater than 3 and smaller, and values of x smaller than minus 3. So we see I reported minus 3 here, 3 here, so plus here on the interval between minus 3 and 3. The parabola is negative, so minus, and for x equal to minus 3 and x equal to 3, we have the point of intersection of the parabola with the horizontal axis. So y is equal to 0. So full point and full point. Now study the sign of the denominator. What does graphically represent the denominator? Y equal to 1 minus x squared, without doing computation, please guys, do it with me, is a parabola. Which are the point of intersection of this parabola with the horizontal axis? You have to set 1 minus x squared equal to 0, from which you get x squared equal to 1, and from which you get x equal to minus 1 and plus 1. So I reported already minus 1 and plus 1. The parabola is concave because the coefficient of x squared is minus 1. So what I'm saying essentially is that you have a parabola. Okay, I did it poorly, but a parabola like this, minus 1, 1. So here is minus 1, here is 1. You see that our parabola is positive for values in the interval minus 1 and 1, and is negative for values smaller than minus 1 or for value greater than 1. So I wrote here 1 minus x squared. Then you see the minus here, and in the middle I reported plus. Guys, you see here at minus 1 and at 1, I should have, no, I should not have, but I'm kidding. I should have put full point. Am I right? No, I'm not right. Why? Because this is the denominator. And remember that the denominator of a fraction, a denominator must be always different from 0. At minus 1 and at 1, the denominator is null, but since it is a denominator, here you have to either report empty circle or a cross to mention the fact that here the function has no sign, because here the function at x equal to minus 1 and at x equal to 1, the function, or this fraction, is not defined. Now, study the sign of the ratio, of this ratio. Plus times minus is minus, minus times minus is plus, minus times plus is minus, minus plus, plus times minus is minus, and here you have a full circle, here a full circle, and here instead a cross. So this is the sign of the ratio. And now, only now, you go back and you look at the sign. You want to find the intervals of values of x making this ratio strictly positive. So you see this interval and this interval. You see, here I reported the cross, and see, why did I report an empty circle? Or if you want, you can either report again a cross, or I reported an empty circle here and not a full point. Because minus 3 and 3, yes, they belong to the domain, but we are at a point at which the function has this ratio is equal to 0. And here we have strictly greater and not greater or equal, okay? If we had greater or equal, then we would have also considered this point and this point. But since we do not have this sign, so we do not have this sign, but only strictly inequality, we have to exclude this and this. Now solve it, write it by using sets. So x belonging to the interval -3, -1. Both extreme are not included. Union 1 and 3 and both extreme are not included. Okay, now guys, now we do a break. Okay, we do a break now. I'm sorry for the beginning of the lecture. I hope it still works. Now you can go to rest, guys, and then we will talk. Unless you have a question, obviously, if you have a question, you can ask me. Let me see in the chat if you wrote something. Okay, thank you guys for what you wrote. However, I uploaded everything. Ask to your colleague, but I uploaded everything on this chat. I mean, uploaded the yesterday folder also in file among the teaching material of the course. Maybe you see it if you close for a moment if you go outside this room for a moment and you look at the chat, but above the chat you have a file, documents, and so I think you can download it. Okay, guys, we do a break now. Okay. Are you still alive, guys? Do you have question, guys, for me?
No, sorry, just for how long the break will last, so we can...
15 minutes, okay? 15 minutes.
Thank you, thank you.
Okay, thank you, thank you. See you in 15 minutes, okay, guys?
Okay, thank you.
Thank you, guys.
No, tranquilla.
Okay, guys. Are you ready? Okay, thank you, thank you, thank you, thank you. Do you see my monitor, the PDF?
Yes.
Oh, thank you, thank you. Guys, we are going to look at the two kinds of exercises related to the straight line, related to the parabola, and related to inequalities. And in particular, and then we go on with the theory, with the review of function. But look first at these two exercises. Exercise, the first one, find the region of the plane, plan or plane? Plan, not plane, plan, defined by the following system of inequalities. So x plus y smaller than 1, x smaller or equal than 3, and x plus 1 greater than 0. We want to find the region of the plan such that all these three inequalities are satisfied. So the solution, this kind of exercise, requires a graphical solution. In particular, guys, we start from the first inequality. You see, it's not an inequality like the previous, because here we have also y, okay? We have x plus y smaller than 1. So I start from the first one. Consider first the associated equation. Which is the associated equation? I start from the first one, okay? The associated equation is x plus y equal to 1. This is the equation of a straight line. Write it in explicit form. That is, you have to find y. Y equal to 1 minus x. So the first step consists in plotting the graph of the straight line y equal to 1 minus x. If you remember, to plot the graph of a straight line, we need only to know 2 points belonging to the straight line. One, for example, can be the point, remember this is q, so the point 0, 1, because when x is 0, okay, y is equal to q. So this is the point, 1 point. Another point, for example, can be the point of intersection with the horizontal axis. If you have question, guys, turn on your microphone, okay, or some problem. Okay. Okay, guys, let me see. Dove siamo? Here. How can you find the point of intersection of this straight line with the horizontal axis? The horizontal axis, x, has equation y equal to 0. So simply put 0 here, you get 1 minus x equal to 0, and therefore x equal to 1. So we find out that the straight line passes through this point and this point. So I plotted the straight line with a non-continuous line. This is the straight line. Okay, this is the straight line, the one I'm touching. Okay. Then look our inequality. Our inequality, if you want, you can rewrite our inequality as y smaller than 1 minus x. So along the points along the straight line are the points such that y is equal to 1 minus x. For points above the straight line, okay, the y, for example, if you take this point, which is perfectly above this one, for the same value of x and 1, the value of y is bigger. But we want the values of y such we want the values x and y such that y is smaller than 1 over x, so 1 minus x. So the points satisfying this inequality are the points below this graph, the graph of the straight line. Above the straight line, we have points xy such that y is strictly bigger than 1 minus x. Along the straight line, we have points such that y is exactly equal to 1 minus x, and below the straight line, we have points such that y is smaller than 1 minus x. So I cancelled the region of the plane that does not satisfy our inequality. So I cancelled this region of the plane, which is above and also on, above and on the straight line, above and on the straight line, because the region of the plane in which this inequality is satisfied is all this empty area below this straight line. Now consider the second inequality, because the inequalities must be jointly satisfied. So the second one established that x must be smaller or equal than 3. So again, consider the equation x equal to 3. We had a smaller or equal, I think. Yes. Then let me check. Okay, so smaller or equal than 3. Put a equal because this was what I requested. So consider the associated equation x equal to 3. X equal to 3 is the equation of a vertical straight line. So passing through 3. What we are required, the second inequality is required that x must be smaller or equal to 3. So I cancel the region of the plane on the strict right of 3, because on the strict right of 3, we have all points with axis x greater than 3, because along this straight line, we have all the points such that x is equal to 3. On the left, we have all the points here, 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 everywhere, all the points such that the axis is smaller than 3. So I cancel this one that corresponds to points whose axis is strictly greater than 3. So since I do not cancel this vertical straight line because we have the equality, instead I plotted it with the continuous line. In the previous case, I used a non-continuous line because we had a strict inequality, and so the point of the line does not satisfy the inequality. On the contrary, the second inequality is satisfied by the point on the line of equation x equal to 3. So I cancel this part. Now, I consider the third inequality. The third inequality was y plus 1 greater than 0. Consider the associated equality, which is y plus 1 equal to 0, from which you get y equal to minus 1. Plot graphically the equation y equal to minus 1. So you know that it is an horizontal straight line. And in particular, we need to cancel the region of the plane. Guys, this inequality can be written as y greater than minus 1. So y greater than minus 1 characterize all the points that lies strictly above the horizontal straight line. We want all the points that lies above. So we cancel all the points below and on this straight line. So everything here is cancelled, and here you see I didn't do a non-continuous line, but I didn't color it. So this means that also the points belonging to this straight line does not satisfy our equality because it's strict. Let me see if it was strict. And then we saw together if I, yes, it was strict. So strictly greater than minus 1. Then let me see if I did correctly. Now you have to find the region of the plane satisfying all these three inequality. You have to put together all your previous results. So here you see I cancel everything on the strict right of 3. here I cancel everything above this straight line and on the straight line, because you see that I plotted the straight line with a non-continuous line. Then this here, guys, you have the equation y equal to -1, and I canceled everything below. You see that here the straight line of equation y equal to -1 has been plotted with non-continuous line. So after deleting, guys, cancelling in a unique graph this area, and this area, you get the region of the plane which satisfies the system of inequality, which is given by this colored in blue. Obviously, you can continue here with this straight line, continue with the straight line. Okay, so you see it's an open, because it's an open, it continues, okay, you see. So this is the area. Sometimes solving inequality of this kind is useful, for example, when you have to find graphically the domain of a function with several variables. Sometimes this can be useful. I show another example and then we stop, we go on. But please, I ask you to make a modification because I did a couple of typos here. So guys, pay attention. Second exercise, find the region of the plane by solving the region of the plane defined by this system of inequality. Please, here check, you have to write y, please modify y smaller or equal than minus x squared has been cut, so minus x squared plus 2, and cancel this one, okay? Then y greater or equal than 1, x greater or equal than 0. So we want to find the region of the plane defined by this system of inequalities. How can we do? We have to perform exactly the same steps we performed previously. First of all, we start from the first inequality. Y smaller or equal than minus x squared plus 2. Guys, consider the associated equality. What does y equal to minus x squared plus 2 represents graphically? You should know very well that this is a parabola. In particular, which is the coefficient a of this parabola? A is equal to -1. So the parabola is concave. Do we have point of intersection with the horizontal axis? You have to set essentially minus x squared plus 2 equal to 0. So minus x squared equal to -2, change the sign, x squared equal to 2, x equal to plus minus square root of 2. Okay, so report this point here, which is the point of intersection with the vertical axis. Well, the point of intersection with the vertical axis is obtained when x is equal to 0, but when x is equal to 0, obviously the value of y is plus 2. So we have this point. Obviously, guys, you see that this parabola minus square root of 2 and square root of 2 are symmetric. Okay, so obviously the vertex lies in the middle of this segment at 0. So this means that when x is equal to 0, your parabola reaches the vertex. So obviously the vertex is also the point of intersection with the vertical axis. So plot the parabola. And now reason with me. The equation tells you, and look below. Since I modified here, please modify it also here. You have to copy. You have to write y smaller or equal than minus x squared plus 2 and cancel this, please, as I did here. Okay, cancel this. So we need to find the points xy such that y is smaller or equal than minus x squared plus 2. But guys, which are the points for which y is equal to minus x squared plus 2? Are exactly the points of the parabola. Above the parabola, we have the point such that y is strictly greater than minus x squared plus 2. Below the parabola, here in the interior, you have the point such that y is strictly smaller than minus x squared plus 2. But here we need to consider the points such that y is smaller or equal than minus x squared plus 2. So we need to consider both the points here inside in the interior of the parabola, that is below the parabola, and the point lying along the parabola. So I cancelled all the points, therefore all the region of the plane strictly above the parabola. Now go to the second inequality, y greater or equal than 1. So plot the associated equation. Okay, greater or equal. I told you that 1 or minus 1. So here you have 1. So we need to cancel all the points. Is greater or equal? Let me see. Yes, greater or equal. Greater or equal. So essentially you need to cancel all the points lying below the straight line of equation y equal to 1, because below you have all the y smaller. Instead, this is valid, and everything above is also valid. Then I reported the smaller. Here also we have x greater or equal, so I need to report the default. Maybe I forgot to write it because I did a continuous line. However, add it, guys. Okay, then we'll see if I did correctly. So when x, we need therefore to exclude all to cancel all the points such that x is strictly smaller than 0. Here you have all the points strictly greater than 0. Along the straight line you have the points such that x is equal to 0. Here all the points such that x is smaller than 0. So cancel all the region of the plane made up by the points such that x is strictly smaller. So the point along the vertical line must be considered. Now in the third graph, cancel everything together, this part, and the part above the parabola, and put everything together. Let me see if I did correctly. So we had to cancel, you see, we have the parabola. We have to cancel everything above the parabola, and I did it. The parabola is valid, so I plotted it with the continuous line. Then I told you that you need to cancel everything above the straight line of equation x equal to y equal to 1. Oh, sorry. Why? Perché scrivo? Okay. Yes, here I use not a continuous line, but I should have considered a continuous line. The important thing is that, however, I remember to use a continuous line in the solution. Okay, because this is the equation y equal to -1, and I should have, to be more precise, use a continuous line. However, I did it in the solution, so there are really no mistakes at all here, so you don't need to modify. So below the line, this line, probably I did with a continuous to show the non-continuous to show the difference. I don't know. However, everything below must be cancelled, and everything on the right of the axis must be cancelled. So if you do it, you see that you have only this area which is completely clean. And in particular, remember, we have all there is an equality here and an equality here. So all the borders of this picture, of this region of the plane, must be considered. So the border is given. So the solution is given by everything inside this picture, which can be seen as a trianguloid. A trianguloid because it seems a triangle, but it's not a triangle because this is not a straight line, this one. So you have the perimeter of the parabola here, which belongs to the solution. You have this vertical segment, which belongs to the solution, and you have also this horizontal segment that belongs to the solution. So the solution is given by the colored area and all the perimeter. So, okay, this is a region of the plane. Okay, guys, finally we finished this presentation. Okay, guys, now we go back. So I needed to do it for an introduction, but repeat, our goal, which is our goal, is to introduce the function. Okay, but I needed to review at least a little bit about inequalities and the final type of exercise, because sometimes this analysis can be useful when you solve other problems. If you need to find represent graphically a domain of a function with several variables, maybe sometimes you have to use this such type of graph in the future. Maybe. And also, Professor Dieci asked me past year to do a couple of exercises like the last two we did together. Now we go back to our main goal. So to see elementary functions. So we open again the file we have already opened yesterday, and which was, let me share with you, which is this one. We go back, function of one real variable. Remember, yesterday we saw generalities. First, we saw generalities about function of one real variable. Then we saw how to apply, we saw again the application of these generalities in two particular cases. The case of the most elementary function, which is the straight line written in explicit form, which is y equal to mx plus q, and then the parabola. Okay, in general, now we're going to see all elementary function. Elementary function are functions that does not require a complete study in order to, a complete rigorous study in order to plot them. And sometimes with Professor Dieci in the real course, you are not doing exercises like this, but sometimes a step requires the solution, requires that you are able to plot a graph of an elementary function immediately, but not because the final goal is to plot the elementary function, because it's only a small step inside a bigger exercise. Okay, so elementary function. Well, the most kind of elementary function is represented by the so-called polynomial function. Here I provided the definition of a polynomial function, and then we'll see a couple of examples. Fx is equal to an xn plus an minus 1 x raised to the power n minus 1, etc., 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 plus a1 x plus a0. Well, this is a polynomial function of order n. Why this function is called polynomial function? It's called polynomial function because the second inside is a polynomial, and the variable is the variable x, so it's a polynomial containing powers of x. In particular, it's called polynomial function of order n because the x with the highest degree has degree n. So it's a polynomial function of order n. This is its general representation. To characterize a polynomial function of order n, I tell you a couple of them. For example, if you have an raised to the power xn stop, this is already a polynomial function of order n. If you have a polynomial function like, for example, 2 times x to the power 3 plus x, this is a polynomial function of order 3. The requirement to characterize a function as a polynomial function is that you have only powers of x, and the powers of highest order has degree n. The domain of a polynomial function is all the set of the real numbers. So a polynomial function is defined on all R. A0, A1, AN minus A2, etc., etc., AN minus 1, AN are coefficient, so they are constant number. Have you ever seen polynomial function with me? Yes. A straight line, guys. A straight line. How can you write a straight line? Or maybe I wrote, don't write because I wrote everything below. Yes, I think I want to show easily, simple. For example, l'ho fatto quel caso lì. Vedere. I showed only some cases, but okay, we'll show very quickly the cases. I wanted to show it better, but or maybe, guys, I can, okay, here I did all the cases. Okay, no, I want to show. I did all special cases, but can I show you quickly the main 2 cases? Because really here, you don't have to study these cases. What I wanted simply to tell you here by doing all these cases is that parabolas and straight line are special cases of polynomial function of order 1. To summarize all these cases, but that you don't really need to study, guys, okay? You don't need to study them. Think to a polynomial function. For example, start from this one. Fx equal to a square sorry, a2 times x squared plus a1 x plus a0 is the equation of a parabola. In fact, which is the equation of a parabola? If you want to use f of x, is ax squared plus bx plus c. So this is a parabola in which obviously a2 plays the rule of the constant a1 plays the rule of the constant b, a0 plays the rule of the constant c. So you see, a polynomial function of order 2 is a parabola. Consider a polynomial function of order 1, fx equal to a1x plus a0. This is a polynomial function of order 1. But look, we studied already a function like this. We studied yesterday f of x is equal to mx plus q. So you see that this is the equation, a polynomial function of order 1 is the equation of a straight line in which a1 plays the rule of m, of the slope, a0 plays the rule of q, the intercept. So you see, a polynomial functions is a general class of function that includes specific function like the straight line, not the vertical one. Remember, the vertical straight line is not a function. It includes the straight line, it includes the parabolas, it includes, for example, here I did several cases, but who cares? For example, yesterday we saw another function. Guys, writing f of x is like to write y, okay? So it's the same thing. F of x equal to q, or y equal to q. This is an equation of a straight line parallel to the horizontal axis. Well, if you set all the coefficients to be equal to 0 in our polynomial function, with the except of a0, you get f of x equal to a0. So a straight line parallel to the horizontal axis is like a polynomial function of order 0. So I want to say that all the functions we studied until now are special cases of the polynomial function. Maybe someone wrote something, but I don't know. No, I was simply seeing something. Well, I don't know. Okay. So that being said, so special cases, we are going to see some special cases. So one special case is a straight line, and the other special case is the parabola. But there are other special cases, which are called power function. I probably wrote it below. Let me see. Yeah, maybe I will tell the name if I... Special case, guys. Maybe add it if I didn't write it. Another special, I think I wrote it. It's strange that I didn't write it. Let me see. Yeah, maybe I didn't use I did it, but without the name. So special cases, the straight line, then another special case is represented by the parabola, and another special case are represented by the so-called power function, if you want to add the name. I did it. Power functions with integer exponent, with integer exponents. That is, I think I did it. Probably I wrote it below the name. No, I mean, I did it, but I don't see the name. But okay, I just told you. And in particular, guys, power function are function written in this way: y or f of x equal to x to the power n. X to the power n. This is an example of a power function. And you see, this is a special case of a polynomial function in which, guys, look back. This coefficient, etc., etc., and this coefficient are equal to 0. So this term disappears, and an is equal to 1. These are called power function. So a special case is represented by power function of order n, where n integer is 1, 2, 3, 4, 5, or positive integer, natural number. Okay, n is a natural number. In particular, we are going to see two cases. Plot, for example, y equal to x to the power 4 and y equal to x to the power 3. These are two examples of power function, one with even order and the other with odd order. So review together with me the concept we explained yesterday and today. Which is the domain? I told you. A polynomial function, like a power function with integer exponent, is defined for all R. So the domain is x belongs to R. I told you this is a polynomial function of order 4, and in particular, this is a power function of order 4. Guys, is this function even? Is this function odd? Does it make sense to check if this function has symmetries? Yes. Why? Because which is the domain of this function? X belongs to R. If you remember what we studied yesterday together, if the domain is symmetric, there could be symmetries. We are not sure, but we can try. So we try to see if it is even. So we apply the reasoning we did yesterday. Remember, a function is even if and only if f of minus x is equal to f of x for all x belonging to the domain. So we try. Which is f of minus x, guys? Means compute f of minus x. Do everything rigorously. F of minus x means take your function, put inside x minus x. So f of minus x is minus x raised to the power 4. So you have to multiply minus x to itself an even number of times. Minus times minus, an even number of times gives plus. So what you get is x to the power 4. But x to the power 4 is exactly our original function, y, which is f of x. So this is equal to f of x. Look at the chain of equalities. We have just shown that f of x minus x is equal to f of x. So what does this mean? This means that our function is even. But what does this imply? As we studied yesterday, if a function is even, this means that its graph is symmetric with respect to the vertical axis. So we get already this information. The graph of this function is symmetric, is defined on all R, and it is symmetric with respect to the horizontal axis. Now, I told you we performed this study of the graph without performing a rigorous study of the graph of the function, but we plot it for the moment in an intuitive way because these are really elementary functions. And there are 3 points, as you will see, of interest for this type of function. Are the value of the function when x is equal to 0, and the value of the function when x is equal to 1. So, which is the value of your function when x is equal to 0? We have simply to put inside x the number 0. So f of 0 is 0. So the function passes through this point, through the origin. Then f of 1, this means that you have to take 1, you have to put inside x. So f of 1 is 1 to the power 4, but 1 to the power 4 is 1. Since the function is symmetric with respect to the vertical axis, you expect that f of minus 1 is here. The value is still 1. Try. F of minus 1 means take minus 1, put inside your function. You get minus 1 to the power 4, which is 1. This is obvious because f of minus x is equal to f of x. So f of 1 is equal to f of minus 1. F of 2 is equal to f of minus 2. For example, which is f of 2, guys? F of 2 will be 2 times 2, f of 2, for example. F of 2, guys, will be equal to f of minus 2 because it's symmetric with respect to the vertical axis. So which is equal to 2 to the power 4 or minus 2 to the power 4, which is the same. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so if you have 2 here, suppose 2 is here, go above, and you have 16. Okay, 16. Okay. Another observation, guys, which is the sign of this function? This x to the power 4. So x to the power 4 is always greater or equal than 0. So this means that you can already cancel everything below the horizontal axis because the graph of x to the power 4 will lie always above. By doing this couple of points that I told you, intuitively, guys, okay, this is mine 16, okay, join the points, and what you get is the graph, approximate graph of x to the power 4. What I want you to realize, I can tell it, that if you need to plot x to the power 2, x to the power is not a parabola. It's similar to a parabola, but it's not a parabola. X to the power 6. X to the power 6 also has a very similar shape. X to the power 8 has a very similar shape. X to the power 10. So all the power function with even order passes, guys, I tell you, are greater or equal than 0. They are obviously all symmetric with respect to the vertical axis. They have all a vertex in 0. They all pass it to the point through these three special points. Which is this one? 1, 1, minus 1, 1, and 0, 0. So these 3 points belongs to all the power function with integer and even order. The only difference, guys, and I suggest to do it because if you want to play, concerns how speed the function increases. Suppose that this is x to the power 4, as I did. X to the power 6 is something, x to the power 6, okay, is something like, I'm not able of sure to, no, non ce la faccio, I cannot do it, but it's something like this. I try, guys, I really have troubles. No. Something like, no, I do it very poorly, okay? Then the graph remains below, and then a certain point here. What I want to say, higher the degree of the exponent, lower is the level here in the interval -1 and 1, and bigger instead is the level for values of x greater than 1. Guys, intuitively, why this happens? Consider with me x to the power 4 with x to the power 2, only to get the intuition. Suppose, which is the value of x to the power 2 when x is equal to 1 over 2? X to the power 2 is 1 over 2 times 1 over 2, which is 1 over 4. 1 over 4 is 0.25. Which is the value instead of x to the power 4 when x is equal to 1 over 2 is 1 over 16. That is much smaller than 0.1 over 4. So this means that higher the power, lower is the graph of this function for x in the interval -1 and 1. On the contrary, for values of x greater than 1 or smaller than 1, -1, what does happen? Consider 2, for example, which is the value of x squared, function y equal to x squared for x equal to 2 is 2 times 2 is 4. Which is the value of x4 where for x equal to 2 is 16, is much more higher. Okay, so you have a picture like this. For example, at a certain point, if suppose that the exponent is 100, you have almost, I do it on purpose poorly, okay, it's not like this, but you have something that tends to be like a sort, you see, I used the straight line to plot it. Obviously, as the exponent tends to become bigger and of even order, your graph tends to become closer and closer to a graph made up by a vertical line here, a vertical line here, and an horizontal segment here. It tends, guys, but it's not exactly, because this is obviously is not a function. Why this is not a function? Because you cannot have a vertical line and a vertical line here. But what I'm saying is that bigger the degree, more quickly increases the function for value bigger than 1 or smaller than -1, and more quickly the function tends to be 0 for values of x in the interval -1 and 1, but only to get the intuition. However, the typical shape, non mi ricordo come si cancella, but the typical shape, vabbè, è lo stesso. The typical shape is this one, okay? Of all the power function of x, of the type x to the power n, where n is a natural, that is a positive integer value number with n even. This is the graph typically, something like this, okay? They all pass symmetric around the origin, they are symmetric around the vertical axis. They all pass it through this point, and this point, which are reported here. And you can verify by your own. Take x to the power 6 if you want. Take x to the power 8. Reason about it when you study. Now, this is instead an example of a polynomial function of odd order with integer exponent, which is, again, guys, what is a special case of a polynomial function. So this is a power function of order 3, or polynomial function of order 3. As all polynomial function is defined on all R. And now, is this function symmetric with respect to the origin or with respect to the vertical axis? Does it make sense to search if there are symmetries? Yes. Why? Because the domain is symmetric. So first of all, we try to see if this function is symmetric with respect to the vertical axis. What you have to check if f of x is equal to f of minus x. So f of minus x, which is f of minus x, means takes minus x and put it inside x in your function. So our function is the raising to the power 3. This means that we have to put minus x inside parentheses and raise it to power 3. Since you have to multiply minus x in an odd number of time to itself, minus minus is plus, times minus odd time gives minus. So the result is minus x to the power 3. I'm asking you, is minus x to the power 3 equal to x to the power 3? Obviously not, because here you have minus x to the power 3. So this is different with respect to x to the power 3, which is, and x to the power 3 is f of x. So I wrote that, see the chain of equality, different from f of x. Since f of minus x is different from f of x, our function is not symmetric with respect to the vertical axis. What does this mean? That our function, cosa ho detto? Non mi ricordo what I said. I tell you, is not even, so it's not symmetric with respect to the vertical axis. I forgot what was said. Okay. Now check if it is odd. How can you check? Remember that I told you that a function is odd if minus f of minus x is equal to f of x. So what does mean you have to compute minus f of minus x? Well, we have already computed f of minus x. Minus is in front of f this time, so you don't have to put it inside x. But you have to put minus in front of this one. But this one is equal to minus x to the power 3. So minus, inside parentheses I wrote f of minus x, minus x to the power 3, minus gives plus, equal to x to the power 3. But x to the power 3 is exactly f of x. So we have just shown that minus f of minus x is equal to f of x. This means that our function is odd, and graphically, this implies that our function is symmetric with respect to the origin. Again, I want you to note something. Note that all three special points are the following, which is the value of of y when x is equal to 0. So f of 0 means put 0 inside x. X 0 to the power 3 is 0. So also this function, like the previous, passes through the origin, which is the value of our function when x is equal to 1. Put 1 inside your function and you get y equal to 1 to the power 3, which is 1. So it passes as the previous function through the point 1 and 1, which is the value of x f of y when x is minus 1. F of minus 1 means put minus 1 into x and raise it to the power 3, which is minus 1. So we got 3 points. Last observation, guys, which is the sign of this function. Study the sign. You have a power, guys, okay? But a power to the power 3 is positive when the basis is positive. Which is the basis? X. So this quantity, x to the power 3, is greater or equal than 0 when x is greater or equal than 0. On the contrary, x to the power 3 is negative when the basis is negative, because, for example, minus 3 to the power 3 is minus 27. Okay? So we can cancel. So since we said that when x is positive, greater or equal than 0, that is here, x to the power 3 is also greater or equal than 0. So this means that we can cancel everything below the horizontal axis. So this means that the graph will lie in this quadrant, in the first quadrant. Then when x is smaller than 0, that is we are here, our function is negative. We studied the sign, so this means that we lie below in the third quadrant and not in the first one, so we can cancel it. Then, guys, intuitively, we find out the point 0, 0, the point 1, 1, the point -1, -1. Again, if you want to try, which is the value of x, notice that the value of f of 2, which is f of 2, guys? Sorry, f of 2 is equal to 2 to the power 3, which is equal to 8. So when x is equal to 2, suppose here you have to go above until you touch 8. When x is equal to -2, what do you expect? F of -2 is equal, without doing computation, to -8. Okay, so -2, suppose is here, -2, and then you have to go below until you touch it. So this function, you see, is symmetric with respect to... Oh, let me... Oh, wait, because I need to charge my computer. So I try to talk louder. So you see that the branch of the parabola, the branch for x greater or equal than 0 of this function is exactly the symmetric of the graph of the branch for x smaller or equal than 0. So this is an example of an odd function. As I don't go on on this topic, but I want you to realize that all, as you can imagine, all power functions with odd order, like x to the power 5, x to the power 7, x to the power 8, 9, etc., have a very similar shape. As you can imagine, as we did previously, bigger the order, lower the function here, then it increases faster and faster. Faccio fatica a rappresentare, I have trouble too. Here it increases faster and faster compared to the previous one. Oh, let me cancel. No, I simply tell you because it's hard to plot. Let me cancel. I did it already to speed to it's. So what I'm saying is that for values of n higher, for example, as n increases in the interval for -1 and 1, you have something like this. You have a graph that lies below. Oh, ma non ce la faccio, it's hard to plot it. Below. Okay, then let me try. Then it touches here, then it starts to be more like this. And here again, I try, but I'm not able. I try, yes. Okay, I did it poorly, okay, but suppose that this the graph of x to the power f of x equal to x to the power 3. This could be, for example, the graph of f of x equal to x to the power 5. And all the power functions, therefore, with the integer exponent, which is natural exponent, which is odd, are symmetric around the origin. So they lie in the first and in the third quadrant. They pass it through the origin. They all pass it to the point 1, 1 and -1, -1. All. Guys, with the simplest one you can think, which is the simplest power function you can think. So a special case, in this case, of a power function of even order. X to the power 1. So which is the graph of x to the power 1? Is exactly a straight line, the bisetrix of the first and the third quadrant, and it passes through the origin to the point 1, 1 and to the point -1, -1. It's a straight line. I'm not able to plot it, but it's a straight line. Yeah, this is a straight line. So this is x to the power 1. That is y equal to x, the bisetrix of the first and the third quadrant. All the other, instead, power function with odd order have something, a behavior like this. Okay, as I told you. Guys, no, I think, yes, I think you are tired now. know, if you want, I go on, but if you're tired, would you like I stop now because you did only 15 minutes of break, or would you like I go on until no, maybe you want to rest. I think you want to rest because you have other 3 hours in the afternoon. Guys, would you like to stop now? Okay, that we stop now for today. Not for today, for this morning, okay?
Okay.
Thank you.
Welcome, thank you. Then we start again at 2 p.m. in point, okay? At 2 p.m. o'clock we start, okay? Thank you, guys.
Okay,
I
thank
hope
you.
it works this
Thank you.
afternoon. Thank you.
Very much. See you
Thank you.
this
We will see you.
Thank you. See you
Thank
later.
you.
Now
See you later.
see you later. Have a good lunch, and I stop the recording so it will be available today, I hope, for everybody. Interrompi.